What does it really take to build a robot that can think for itself and walk around just like one of us? It's one of the biggest, most mind-bending challenges in engineering. Well, today, we're going to look at the definitive blueprint that's making it all possible.
So yeah, that's the big question, isn't it? How do you actually do it? I know it sounds like something straight out of science fiction, but this is rapidly becoming engineering fact. And we're not just talking about some factory machine that repeats the same task over and over. No, we're talking about something that can genuinely perceive, reason, and navigate our messy, complicated world all on its own.
The thing is, until very recently, all the knowledge to do this was scattered everywhere, like puzzle pieces in different labs and research papers. But now, thanks to these massive breakthroughs in both AI and hardware, a clear, modern blueprint has finally emerged. This is the guide for the 2025 to 2027 generation of humanoids.
And that blueprint, it's all laid out in this new textbook, Physical AI and Humanoid Robotics. You can really think of it as the go-to manual, the playbook, that brings together all the latest, cutting-edge techniques for today's top robotics engineers.
What's so powerful about this whole approach is the journey it maps out, and its subtitle just sums it up perfectly, from simulated brains to walking bodies. It highlights the two absolutely critical stages. First, you create the mind in a purely virtual world, and only then do you transfer that mind into a physical body that has to deal with, the laws of physics.
So that journey starts not with metal and wires, but with data. It all begins inside a powerful computer simulation with what's called a digital twin. This is a perfectly replicated, physics-accurate virtual model of the robot. I mean, every single joint, every sensor, every motor is recreated right there in the digital world first.
And this process is really a two-parter. First, you build that digital twin, that exact virtual replica. Then, you start to train the AI brain, and this is where the real magic is. This is where cutting-edge AI models come in, and they basically allow the AI to learn how to connect what it sees in the simulation with the physical actions it needs to take, all before a single physical part has even been put together.
But okay, once the AI has completely mastered its virtual playground, the hardest part begins. Now you've got to transfer that digital brain into a physical body. This is the great challenge, getting a two-legged machine to actually walk and balance in the real world.
And this is the core of the problem, what engineers call the sim-to-real gap. The virtual world is a perfect sandbox, right? You can run millions of tests, fail 1,000 times a second, and it costs nothing. But the real world, it's filled with uneven surfaces, unexpected gusts of wind, and very, very real consequences if the robot falls over. Bridging this gap is where all the theory finally meets reality. So who are the people tackling this incredible challenge head-on? Who is using this very blueprint to build the next generation of robots that are, gonna walk among us? It's this whole global community of brilliant minds. We're talking about advanced students in university labs pushing the absolute boundaries of what's possible. We're talking about seasoned engineers at the world's biggest tech companies, and of course, the university researchers. These are the architects using this knowledge right now to define the future of robotics. This really brings us to an incredible moment in time. For the first time ever, the roadmap is clear and the tools are more accessible than they've ever been. The big question is no longer how we build them. Now that we have the blueprint, the real question is, what will we build next?